Hello, everyone. It's a great thing to be here in Riga. It's actually my first time here in this town, in this country as well. So it's great to be here among such incredible speakers, incredible audience. Thank you very much for coming up here to see my talk. And without further ado, most of us have probably worked with legacy code. And refactoring is something that we do in our daily work. So during this session, we will refactor live a part of some legacy system, and we will approach the problem pragmatically. We will identify and solve issues live, but there won't be much of theory there. We won't be talking about what is refactoring, why to do it, or when to do it. We'll just see how to do it and how to do it in a safe way. During these 15 minutes, we won't be able to lead our code to perfection, but we will surely see the approach that we should take in order to get with our code we would like to be in the future. Throughout the session, we are going to follow one rule that actually defines what refactoring really is. And the rule is following. Refactoring cannot change the external observable behavior of existing code. And this is how it goes. Welcome to the session. My name is Bartłomiej Słota. I'm a software engineer. I'm a consultant at Bottega IT Minds. I'm passionate about OOP, domain-driven design, software architecture, software craftsmanship, microservices, and all that stuff. And in personal life, I'm a husband, father. I love heavy metal music. I play guitar. I love angling, trekking, and that's all about me. I currently work in the energy industry. And with the consent of my client, I can briefly tell you a few words about what I'm doing professionally today. And today I work for Vattenfall, which is a Swedish power company whose mission is fossil-free in one generation. And Vattenfall is also e-mobility infrastructure and services, including charging points for Tesla and other electric vehicles. And today, we are in the process of migrating the old e-mobility platform to new microservices running on Kubernetes in Microsoft Azure Cloud. And the big part of this migration is refactoring. It is extremely crucial for us to keep the old living functionality that earns us money alive. So this is yet another reason why refactoring is so close to me. Now, let's move to the code then. What we have here is a part of some legacy system that's responsible for managing a library. And imagine that we just stepped into the project. And all we know from the business perspective is the fact that a patron, a client, in order to lend the book, he or she needs to place the book on hold first, so make the reservation. And this logic is basically kept here in the BookService class and in the PlaceOnHold method, right? If we look at this class, it is kind of a luxury legacy code. We have only 80 lines, right? So it is as luxury as Polish vodka named luxury. Apart from the name, it is this is all it has in common with luxury. So this is how it goes. We step into the project. We don't know what's going on, but we know that we need to fix these things up. And what we see here is that there's a lot of if statement. There's a lot of variables of primitive types, some control Boolean flags and stuff. And what can we do to neutralize all these bad things in code to make it a bit more understandable for us so that we know how to fix it, right? So what we could do is that we could walk through this code and try to group particular parts of it and extract it to methods and find some meaningful names. So let's try to do it. What we have here in this line is that we are getting some book from database. All seems to be clear. We are getting patron. Here's some crazy flag. We don't know what it means right now, so let's just leave it. We are checking if the book is not equal to null or patron is not equal to null. And we as Java developers, most of us probably are Java developers, we are used to optionals, right? So it would be best if our book DAO could return us an optional. But the slightest thing that we could do to make this thing better is to create a method like this. There is a book, and there is a patron. And let's go further. And next, what we are doing is that we are getting the collection, the list of holds. We are checking the size, checking if it's not greater or equal to 5. We are negating this condition. And what we are really checking here is if our patron does not have more than some probably maximum number of holds. So how we could call this method? Maximum number of holds is not reached by patron. And let's try to read it. If there's a book and there's a patron, and if maximum number of holds is not reached by patron, it sounds like medieval poetry, right? The better the code sounds when we read it, the easier it is for us to understand it. Let's move on. What else do we do here? We are getting the reservation date from the book, and we are checking it against the null. So what does it mean for us if the reservation date is null? It means that the book is still available. So what we can do is that we can inline this and name this condition as is available. This sounds a bit badly. Is available book, but it's still better than checking something if something is equal to null or not. And you can see here is the last, so to say, branch or the last part of our tree of ifs, and it ends with setting up the flag to true, which suggests us a bit that this flag might be an indicator of a success of this method. We are also here persisting the result of our computations, and this is actually the core of our method. So let's extract it into PlaceOnHold method, and let's move further. And indeed, if the flag is true, so if we manage to place the book on hold, we are adding loyalty points to patron. This is some crazy switch statement. Let's leave it for now. And next, if patron qualifies for free book, we are doing some strange thing here. We are sending an email to our customer service, so we are sending an email to our employees, and we are telling them that patron of this ID has gathered this number of points, and there's a free book as a reward for him or her. So let's extract it into a method called send notification about free book reward for. Yeah, and the key thing here is that the names that we used cannot be accidental. It is extremely crucial to use the business, the domain language over here, because it helps us in communication between developers and between developers and business as well. If we are not sure what name should we choose for this particular piece of logic, just take your PO for a coffee or organize some event storming session to get that knowledge from somewhere. Do not mess things up over here, because the language is a half of our success. All right, but wait, have we just refactored a production system without writing test first? The guy said at the beginning that it will be a safe refactoring or tests. And we made this exception because the only thing we did here were refactorings supported by our IDE. And these are usually safe refactorings because they are done by the tool that we trust. And what they gave us is readability, and thus it will be easier for us to test it because now we know what's going on here. But this is not always the readability that forces us to refactor the code before we test it. And here, Michael Feathers, in his book entitled Working Effectively with Legacy Code, called such phenomena as legacy code dilemma, which means that in order to change the code, you need to test it. In order to test it, you need to change it. And this is exactly what we need to do in our code, because what we have here is that we have no simple way of instantiating an object of this class. There's no constructor. So far, it's been done by the IOC container, right? So what we need to do in order to test this class, we need to get rid of this auto-wired stuff and create a constructor. We could also add final if we like, and create a constructor. And now we are able to create a test. So let's create one. But wait, how should we approach testing in that case? This method seems to be a bit complex. Now, the best strategy for testing a new code that we are starting working on is to choose the easiest possible path, the shortest path, the shortest branch. Because if we choose to start testing, if we correctly place the book on hold over here, then we would spend force on setting up this whole test. So the easiest part for us, the easiest strategy for us would be to test the scenario when there's no book or there's no patron, because then we won't access any of this if statements, but we'll start building the test base, right? So this is the strategy. But in order to create this book object, so let's maybe move to the test. In order to test it, we need to create it. So book service, new book service. We would like to test this class in isolation, which means that we do not want it to communicate with database or send an email. So we just cannot use the original classes like book DAO, patron DAO, or notification sender. And here, in the context of dependencies, we need to introduce the concept of a seam. A seam is such place in the code where we can introduce some other behavior without changing the code itself. It sounds messy, but we will clarify it soon. If we look at this line, book DAO, get book from database, what we can see here is that we would like to test this particular code as it is, without changing it. But we would like the book DAO, get book from database, not to communicate with database. And we can get such things with the help of mechanisms like fake objects, mocks, or stops. And because in our case, what we care about is the result of these methods, a particular state of the book, we'll go for stops. And this is what we are going to create now here with the help of Mockito. Private book DAO, mock, book DAO, class. Yep. And same thing we need to do for patron DAO and notification sender. Right, we need to fix names here, patron DAO, notification sender. And the last thing over here, patron DAO, and notification sender. Great. And now we can pass them to constructor. Book DAO, patron DAO, notification sender. All right. So let's start with writing the test for the easiest scenario, okay? And as we already mentioned, the easiest scenario is the one when there's no book, right? So should fail to place not existing book on hold. Yeah. What are we testing here? Because we are checking if should fail. If the result will be false, because the flag that was over there means if we succeeded to place the book on hold or not. So let's assign the result. Book service, place on hold. For example, book with ID 1, 10, and 100. And because we care about our colleagues that will be reading this test, to save their time, we will name this constant, right? So let's call it ID of not existing book. Same here. ID of not existing patron. And this is period in days. Okay? And what we really expect from this test is assert false result. And now we're going to run this test, but with the coverage. And we'll see what it gives us. If I open the class now, our IDE is telling us which parts of code have been penetrated and examined by our test. And what you can see here is that we checked this exception, but we didn't enter any of these if statements. So you can see that our IDE provides us kind of a guidance of what are we really testing. And it can be very helpful when working with new code base, but what we will see in a second, we need to be careful. Okay, let's get back to the test. And the next test would be to enter this if statement, but not to enter anything more. So now we want to have a book, have a patron, but we want to have a patron that already has maximum number of holds. So let's write such test. Test should fail to place book on hold when patron has max number of holds. Long name, but descriptive. Okay, now we need to set up a lot more things, because now we need to have a book that is available. Available book. We want to have a patron that is a patron with maximum number of holds, right? Or I should write here with max number of holds. Yep. And when? Again, we care about the result, Boolean result, BookService, PlaceOnHold. And we now what we pass is the ID of the book, ID of the patron, and finally some period in days. And then again what we expect is to get the result equal to false. Now we also need to create this objects finally. So let's create two methods, book, available book. And before the presentation, I already prepared a set of test fixtures to create such objects a bit quicker. So I will use book fixture here, available book. But before we return the book, we need to set our stub. So we'll write book, book DAO, get book from database from this book ID, then return book. And same thing we need to do for patron with max number of holds, and same here, patron. We also have a patron fixture over here, patron with max number of holds, return patron, and again we need to set up the stub when patron DAO, get patron from database for this ID, get patron ID, then return patron. So let's run this test again with the coverage so that we can see if we indeed penetrated what we really meant to. And what we can see here is that indeed what we checked is this condition and this one. So we see the pattern, right? We test the code from the shallowest branch into the deepest branch. We won't spend more time on testing it, so what I'll do now is that I will switch to next revision in my code. Git stage, what I really want, git checkout stage 1. And now what we already have here in this stage is a full set of tests with stubs. Now let me run this set of tests with coverage again. And if we have a look at what is here in our IDE, you can see the green bar over here. So this is green. Imagine we covered the whole method. Does this mean that our tests are good? Let's try to find out. Let's get back to our tests and run them once again. By the way, have you seen the green and the red bars before? Sorry, it was the intention that if we run the test with coverage, I will tell you about what you should see here. Is that over here, there are bars with green or red color. If the bar is green, then it means that we penetrated a particular line in code. If it's red, this particular test hasn't been there. I thought you see it. Sorry. Anyway, the test passed, which means that we cannot rely on this test. Why is it? Because these tests care only about the state. We have used stubs. We didn't care about any interactions with our dependencies. In order to test state, we use stubs. In order to test dependencies behavior, we should use mocks. So now, there probably might be a temptation to just add a few verifications in any of these tests, right? But what we need to do is to resist this temptation. Because a good test is a test that fails for one reason only. And when we test the state and the behavior, there are at least two reasons for the test to fail. So what we're going to do now is that we're going to write some interaction test for the most interesting part, which is the successful, let's say, processing of placing on hold. So I'm going to copy this and name the test should save book and patron when succeeded to place book on hold. The setup is the same, but now we do not care about the result. And what we care about is if we call the update methods of our mocks. So book DAO. We say that we expect it to be called at least once, method update, for, let's say, any book, to simplify it. Of course, we could and should be probably a bit more strict about what exact object are we updating. But for the simplicity, let's keep it like this. Patron DAO, update any. So if I run the test now, we expect it to fail because we commented 2 lines of code, right? And now if we get back to the book service and uncomment it and rerun the tests, we can run all tests again. What do we, yeah, and test pass. So now we have everything tested, both the state and the interactions. So it took us over 20 minutes to build a solid base of tests for one simple method. This is the reality of working with legacy code. I'm sorry. But this is the only way to make our refactoring safe. Okay, so again, I will switch to yet another step. Okay, now the question is, what can we do, or how should we approach the refactoring in such case? Where should we start it? And here, as opposite to testing, we should start in the deepest place in the code, which is over here. Why here? Because here, the impact of the change is the lowest. Because if we start a refactoring over here, and if we mess up something, it could cause a cascade of failures in this method and all these tests. So the safer place to start with is over here, particularly in this line 57. Okay, what we really see here is one of the ugliest part in this code, the ugliest thing. Whenever we see a chain of method invocation, and it's not a stream processing or something, it should attract our attention. What we have here is that we are accessing patron's private collection of holds and we are manipulating it. What does it mean? It means that, first of all, we violate the hermitization of a patron object because we might, and this object might get into the state in which it shouldn't ever be because the patron doesn't know that we are manipulating anything. This is the first thing. The second thing is that if we violate object abstraction. Abstraction is one of the key things in object-oriented programming, right? Now the logic is spread all over the application. And the class seems to be just dump a naming data structure. And finally, there's also feature envy, because in BookService, we wish we had direct access to this collection and do something, right? So, okay, enough complaining. Let's fix it. And we'll fix it by starting with writing tests in a patron class. But because what we're going to do now is to move it to the patron, because this is where this method really belongs. Of course, one could say that, okay, why are we writing tests? We already have tested the BookService class. Now, the first thing, this test was valid as long as this method was the part of the BookService. Secondly, what if we eventually decide to move the patron to a separate module as a result of our refactoring? Then the tests of BookService won't give us anything. But now we'll have a solid base, a well-tested class that we can move into a separate module. So let's write the test. Void should place on hold and given book book is, available book. We will use the fixtures that are already there. Patron, we want to have a patron without holds. Okay. And when patron place on hold book, then what should we assert here? Well, if we place the book on hold, assert equals, the number of holds that patron has should be equal to 1, right? And what's more, we also expect that the only hold that is there is exactly the one that we put here. So we will get holds and put the ugly get 0 over here. Okay? This code does not compile. So let's move to the book service and let's try to find out if our IDE could do the desired refactoring for us. So let's extract this method, patron PlaceOnHold. Good. And let's move it to patron. It is almost as we imagined it. Apart from this getter, we don't want this getter. So yeah, so let's run this test. And patron test, now the code compiles, let's run it. Yeah, and it looks nice. So what we just did is we fixed up the encapsulation and the abstraction. Okay, let's move. Let's get back to the part where we finished. But before that, I need to change the revision. Okay, so if we get back to book service, what we also do have here are 3 setter methods that are being called here. Now, the fact that we break the hermitization of each of these fields separately is not as dangerous for us as calling them at once. Why is it? Because such code suggests that these 3 invocations are not situated next to each other by accident. And if they are not situated here by an accident, they're probably part of one operation. If so, if client forgets to call one of these setters, again, the book might enter a state in which it should never be. So again, what we should do is to move these parts of code, encapsulate it in the method, and move to the book. First, we'll write a test. Book test. This time, it will be test like this. Should be placed on hold. Book. Available book. Good. Patron. Sorry, this time we don't need patron. We just need an ID. If we look at this method, we only need ID of the patron, right? So let's get back to the book. Test, patron ID of sum and value. We also need period in days equal to 100, for example. Then when we call book placed on hold for patron ID and period in days, then what should we check in this case? Well, generally, when we are moving some methods or something, we should keep the contract. So we should check these getters here. But the most important part when we are doing refactoring is fixing the design. What are we going to fix here? If we place the book on hold, it should not be available. So let's check it. Assert false book is available. Good. And yeah, the code does not compile. So let's check if we could do the same thing with our IDE. Let's extract the method placed on hold. Good. Let's move it to the book. And what we see here is that the method signature does not comply to what we just wrote in our test. The point now is that refactorings from our IDE might help us, but IDE does not care about the design. If we haven't written the test before, we would leave it as it is. We would have bidirectional dependencies between patron and book. You see the role of the test now? Good. So we need to fix it. Patron ID, patron ID, patron ID over here as int. Good. And we no longer need these setters, so let's inline them. And it turns out that they are not used anywhere. And if we zoom out this class, you can see how consistent it is now, how small it became, right? So it is visible for us that we are fixing the design, right? So what we need to also do now is to get back to the patron service, because now the method signature is a bit different. Patron, get patron ID. And now what we are also missing here in the book test is the implementation of the isAvailable method. But we already discussed what isAvailable really means. So boolean return reservation date equal to null, right? So now if we run this test, or maybe we should run all tests because we changed also the book service. So let's run them. Yep. And let's see what happens. Good. And test passed. And what we can also do, because we already introduced the method isAvailable in book, we can also apply it over here in the book service, right? Over here, we can use book isAvailable. And now we can get rid of this method, and thus we simplified the book service a bit. So let's rerun the test again. Okay, it worked. Yep, let's move to yet another revision. And yet another problem that we have here is this one. Maximum number of holds not reached by patron. There's nothing wrong in calling a getter and checking the size of the collection. There's nothing wrong. But this rule, we see that all information required to validate this rule is already inside the patron. So we could think that this method belongs in there. So let's make one small exception. Don't write test because I want to discuss it further. Let's move it just like this. Move to patron, and now it is, the name is not too fortunate, so let's name it has not reached max number of holds. Now, what happened? Now, the question we should ask when doing such things, such refactoring or writing code every day is, does this part of code belong in here? What did last refactoring improve? Have we improved hermitization? Maybe. No. Have we encapsulated the business rule in a proper object? Yes? Okay. Is it a business and domain rule? Or was it specific to the book service? The point is that sometimes we do not have enough information to answer the question, does this part of code belong in here? In order to find the answer, if this really belongs in here, we need to know if this rule is applicable always whenever we try to place the book on hold, or maybe this is specific to this particular application. And we need to ask business people if there are any exceptions. For example, what happens if a patron calls us? Is the limit equal to 5 or maybe 2? And what if the patron comes into our physical library and tries to place the book on hold? Is the limit equal to 5 or maybe 10? So we can see that it is not always that simple that we can, you know, move around all these methods. I think it's in the patron, so let's move to the patron. It's not that simple. If the rule really is applicable always, regardless of the use case, then the proper place would be inside the PlaceOnHold method of a patron, because it is applicable always. If it's not always the case, and it differs from use case to use case, then this is the place to call this. You see? It's not that obvious. Assuming that we had a talk with our PO, and he said, this rule is valid, it should be validated whenever we place the book on hold. So now we can assume that we can move it into the patron PlaceOnHold. To make it more readable, I will inline this back. I will defactor it. Okay, and now if we agree that we should move it over here, this part over here, it's not that simple again, because this if statement is a condition under this part of code is going to be executed or not. So if we remove this if statement, now PlaceOnHold method cannot return void anymore. It needs to somehow signal the result. What options do we have to signal the result if it was success or failure? Now, the first and maybe the easiest possibility could be to use runtime exceptions. But the problem with runtime exceptions, and of course, surround this code with try catch, but the problem with runtime exception over here is that runtime exception introduces some implicit logic that is not that obvious. Because if we look at the signature of the method, we have no idea that it's going to throw an exception until we dig deep into the code. Similarly, if we see the client code, the moment where we execute the code and handle exception can be far away from each other. What can we do instead? We could use, for example, checked exception. Why should we hate checked exceptions? If we look at the method signature, there's already an information that we need to handle an exception. It is a bit better, but in terms of handling the error, the same problems apply over here. So what we could do also instead is that we could go for just returning some object that would tell us everything about whether it was success or not. So let's go for this option, and let's start with writing a test. We'll move to the patron test now. And what we want to check is that test void should return success when book is placed on hold. Right? The setup will be pretty much the same, but now we care about the result. So let's call it, we no longer want any Boolean flags, right? So place on hold result, and let's write something like this, then assert true, result instance of book placed on hold, right? So in order to make this test pass, we need to create, it should be an interface, result. We could also create this class that implements this interface. PlaceOnHold result, good. And we need to make the PlaceOnHold method return the PlaceOnHold result, and this test will pass if we return book placed on hold. Let's run this test. It should pass. Woo. Yep, and the test passes. So the second thing we need to do is to check against the best scenario when we actually cannot place the book on hold because the patron has already maximum number of holds. So should return failure when patron has max number of holds. Okay? Here we need to have a patron with max number of holds. And here, let's call it like placing on hold failed. And again, let's create a class implementing the interface implements place on hold result. And now we need to add proper implementation over here, which means that we need to put the condition over here. Has not reached maximum number of holds. Then this part is applicable then. And in our case, else we return new placing on hold failed. Let's get back to tests and let's run all of those. I will get back to it. Okay. Yeah. And if the test run, now what we need to do is that we need to change the implementation over here because we no longer need this condition over here. And now let's assign the result, place on hold result. Result. Now if result instance of book place on hold. Okay. And then this part. All right. So to be sure that we didn't mess up too much, let's run tests. And all tests passed. Okay, what have we achieved with this transformation? Because the depth of this method stayed the same, but we fixed the design generally. We moved the condition into the place where it really belongs to. Sorry, I just will check my timer. Okay, good. We fixed the design. Now the condition is called whenever we try to place the book on hold. Now, the second condition that that we could work on is checking the book availability. Again, this condition should be valid always when we place the book on hold. Of course, this always should be again checked, because I imagine a situation when there's a VIP customer that that we enable to place the book on hold that is not available, but we do everything for him to find this book. So it is not always that obvious. So always ask business about if it's valid, if it should be valid always or not. So let's assume that it is, and because we are a bit short of time, forgive me for not writing the test first, and just move it. I will just move it and progress with the presentation. Okay. Place on hold. I'll just move it over here, and book is available. I can get rid of this one and this one, and let's run our tests again. So you see, the design is now much better. The method starts looking more and more concise. Now, if someone hates the depth, because we don't like if there are too many if statements chained, because it is very hard to understand what's going on here. Then what we could do with this, we could introduce something that is called a guard clause. We could create a validation over here, and if this condition is not fulfilled, of course, what we should do is to find the proper name for it. We could return false over here, and the rest could be like this. We could get rid of this flag and stuff. But I just want to show you how to get rid of this if statement. But there's one bigger thing that we need to refactor now. So I will just move forward. I hope this is it. No, this is not it. This is stage number 8 probably. Yeah, this is it. Okay, now what we have again here is that we should repeat the question. Does this part in code belong in here? Loyalty points. How loyalty points are connected with placing the book on hold? They're just real derivative of the process of placing the book on hold. What's more, if we have a look at the patron object, which fields are necessary to place the book on hold? It is only the ID and the collection of holds. So these 3 fields are only necessary for adding loyalty points. What can we do in such case? Let's create a class. So let's create a class called patron loyalties, and let's move it over here. I will copy this like this. I will create a constructor for all these fields. And in order to keep the contract, I need to add all getters and setters. What we also can do is that we can introduce a field of this type, patron loyalties now. Call it loyalties. Instantiate it over here. Loyalties. New patron loyalties. And we can pass all these flags here. Flags and primitive variables. Points. Qualifies for free book. Yep. And now what we can do is to delegate all calls to these variables, to these fields, through our loyalties. So this is a boring part of this refactoring, but we need to do it. Okay. So what we could do now is that if we want to get get type, for example, we need to get this loyalties get type, right? This loyalties set type. I'll try to do it as quickly as possible. This loyalties get points. Delegate. Oh, wow. Good. There's some other refactoring which I want to show you. Give me a second. Set this loyalties. Set points. Okay. And similarly here, these are the last two methods. This loyalties set qualifies for free book flag. And the final one, this loyalties qualifies for free book. Now, what did this refactoring give us? Now it gave us something good because we can introduce a getter for loyalties and make refactoring that is called encapsulateField, which means that any access to the loyalties will be redirected to the getter. What this gives us is now if the getter is public, I can inline every call to our loyalties. So this is not even used, so I can get rid of this method. Anyway, get points, inline. Set points, inline. Qualifies for free book, inline. Inline. Move this class away from here. Yeah, get back to patron. How does the patron looks like now? I can get rid of this. Get rid of this. Do you feel it's a better design now? The one caveat is that it is not always that easy to just introduce a field of new type in a class. Because if this class was, for example, a GPA entity, was annotated with the entity annotation, columns and stuff, then it wouldn't be that easy to introduce a new class. It should be also annotated with some embedded annotation or something. Or if we have if we are constructing some SQL statements underneath, it could also be problematic because we should update it somehow. So it wouldn't be, sometimes it is not possible without writing some integrated tests first. So this is the caveat that we need to keep in mind. And I just want to quickly show you one thing, the result of such transformation, git checkout stage 9. And if I open the BookService, what you see here now is, thanks to this transformation, loyalty points no longer depends on the patron object. It depends only on loyalties. Okay, because we have only 2 minutes left, and I think it's high time we start summarizing the presentation. So in this presentation, what we really did is that we only slightly touched the topic of refactoring. There are a lot more things that could be done over here with this application. And if you read the abstract, you may be asking yourself, or maybe myself, where are these patterns, the OOP stuff, the domain-driven design that the guy wrote about in the abstract? It was over there. But I didn't use any sophisticated name in order to get rid of all barriers that may stand between us and all those fancy things, fancy buzzwords. What we really did is that we solved problems that are called bad smells in code, which are described in books, as, for example, the book written by Martin Fowler about refactoring, inappropriate intimacy, setter methods of data class, etc. We use refactorings like extract method, extract class, move method. And all these things improve the cohesion of book and patron, the cohesion from the abstract. We decoupled our book service from the internals of book and patron. We also made a step towards modularity because a new class was born. And now in further refactorings, what we could do is to move all these patron loyalties to some external module. If you're interested in what DDD patterns have we used, we followed tactical patterns like aggregate, invariant, application service, and also domain event. And this answers your question about why have I used an interface to be returned by the PlaceOnHold. Because events are actually children of a domain, of one domain event. It can be success, failure, failure because of something. It can be update of something, whatever. These are domain events. I just didn't call it that way. Right? So what we can see after this session is that every one of us in our projects, every day, in a legacy code, can do the refactoring, right? We can use these patterns. We can use domain-driven design. We can use all these buzzwords, all these technical things that are so popular today without using any sophisticated names. Thank you very much for attending.
Yeah, I didn't see any question in the Slack channel. Maybe there are some questions from the audience. Yeah, we have some time for some questions.
Yep.
How to deal with bugs when you found it while refactoring?
Yeah, what to do with the bugs? The question is, what to do with the bugs when that we find during refactoring? Now, the strategy that I usually take is that I write a test against the bug. This is how I start. You write the test, you stop everything, right? You stop everything. Because this unit test that we wrote and the strategy that we took over here is that we took only the smallest possible step at once. So, you know, the impact that we are doing is very limited, right? So if you limit the impact, then you can stop anytime you like. And if you identify that there's any bug, you just stop it, get back to the last working revision, write test against bug, and fix it.
Okay, yeah. There is no time for more questions.
Okay,
maybe.
I will be here for the rest of the day, so if you have any questions, I will be more than happy to discuss with you. Thanks.
Woo!